Hello, this is lesson 1 of module 2. We are going to be getting into the fraction portion of the lessons. So I wanted to get right into the 6th grade piece of fractions, but we're going to do it in 2 methods. I like those tape diagrams. So I'm going to show you tape diagram method and then standard algebra method, which is what you guys call normal math. So in this space, I'm going to do one question at a time, and then that'll give you a chance to copy it down, and then I'll erase it, move on to the next one. All right, so we're going to look at this question right here, a fourth divided by 5. So the denominator of the first fraction shows how many parts that we're going to have to split that tape diagram into. So we're going to split it into 4 equal parts as close as we can. And then it says fourth. So we're just going to represent this as our first fourth. And that fourth, we got to split into 5 parts. So I'm going to change my direction here. And of course, I got to make it bigger. Happens all the time. So now we have a fourth cut into 5 parts. Okay. So the thing about tape diagrams is that every piece has to be the same. So right now we have 1/4, one of the pieces. So now we have to make them all the same. So a fourth divided by 5, we need 1 piece out of the total. So if we just have this in 5, so we have 5, 10, 15, 20. So our denominator is 20. So we have 1 out of 20. That would be our answer. Standard algorithm would look like this. We would rewrite the problem. All whole numbers are numerators, and the denominator is 1. We're going to bring down this left side fraction. We are going to change the division sign to a multiplication sign. And we are going to do the reciprocal, or the multiplicative inverse, of this right fraction, which means we are going to flip it over. A nice way to remember this is drop, change, flip. Okay. Now we do our numerators. 1 times 1 is 1, and 5 times 4 is 20. Same answer, 2 different methods. It kind of depends on what the directions are saying. If it says draw a picture, you could use a tape diagram. If it doesn't, standard algorithm, whichever works for you. All right, so you can revisit that by rewinding. We're going to make the next one. If you notice on this next one, number 4, it says that we need to split this into 5 parts. And we need 3 of those shaded. So that's my 3/5. And we have to divide this into 5 parts. And we need 3 of them. So our numerator is going to be 3. And we have to carry this through because all parts of a tape diagram be the same. So if we split this into 5s, 5, 10, 15, 20, 25, our answer is 3 parts of 25. Standard algorithm, we rewrite. All whole numbers go over 1. Bring down the left fraction, change the division sign to a times sign, and do the reciprocal of 5/1, which is 1/5. We drop, changed, flipped. We do our numerators. 3 times 1 is 3. Denominators, 5 times 5, 25. Same answer as we got, just standard algorithm. That is what we are going to be doing. Let's do one more just to make sure you've got this. I'm pretty sure you do. It has to be split into 5 parts. We need to shade in 1/5 of those. And that 1/5 has to be divided into 4 equal parts. We need 1 piece. It says it on the numerator, 1. But all pieces have to be the same. So we have 4, 8, 12, 16, 20. 20 little parts. 1 is what we needed. Standard algorithm. Rewrite. All whole numbers go over 1. Bring down the left fraction. Change the division sign to a times sign. Do the reciprocal of 4/1, which is 1/4. We drop, changed, flipped everything. 1 times 1, 5 times 4. Same answer, different method. And as always, this is Mrs. Bobby, and I love math.